Our universe is filled with extraordinary worlds. Some planets are made of molten lava. Some experience storms larger than entire continents. And some are so strange that they challenge everything we thought we knew about planetary science. Far beyond our solar system lies a fascinating planetary system known as the TOI-375 planetary system. This distant system contains massive alien planets orbiting a single star. But what makes this system truly fascinating is how different each planet is from the others. One planet is unbelievably puffy and inflated. Another is a massive gas giant with immense gravitational power. And another orbits its star at a distance similar to where Earth orbits the Sun. These planets are known as TOI-375b, TOI-375c, and TOI-375d. Each of these worlds tells a different story about how planets form and evolve. But before we explore the planets themselves, we first need to understand the star at the center of this system. Because in any solar system, the star controls everything: gravity, temperature, planetary orbits, and even the potential for life. The star, TOI-375. At the heart of this system lies the star TOI-375. Astronomers classify it as a K-type star, sometimes called an orange dwarf star. This type of star is slightly smaller and cooler than our Sun. While the Sun shines with a bright yellow light, TOI-375 glows with a slightly orange tint. If you were standing on a nearby planet, the sky would look very different. Instead of the bright yellow sunlight we see on Earth, the star would appear softer and more orange. Sunsets could look deeper red. Shadows might be slightly dimmer. But despite being smaller than the Sun, K-type stars have an incredible advantage. They live much longer, to shine for about 10 billion years. But many K-type stars can remain stable for 20 to 30 billion years. That means planets orbiting these stars have far more time to evolve. Some scientists even believe that K-type stars may be one of the best places to search for life in the universe. But the most exciting discovery around this star came from NASA's Transiting Exoplanet Survey Satellite, also known as TESS. TESS scans the sky, searching for planets around distant stars. It looks for tiny dips in starlight that occur when a planet crosses in front of its star. This method is known as the transit method. Using this technique, astronomers detected multiple planets orbiting TOI-375. And 3 of them quickly caught the attention of scientists around the world, because they were giant planets with fascinating characteristics. Let's start with the first one. Planet 1, TOI-375b. Our first destination is TOI-375b. At first glance, this planet appears to be similar in size to Jupiter, the largest planet in our solar system. But when scientists measured its mass, they discovered something astonishing. Despite being nearly Jupiter-sized, this planet is far less massive. That means its density is extremely low. In fact, researchers often describe it as a puffy or marshmallow-like planet. Imagine a planet almost as large as Jupiter, but far lighter and more inflated. This happens because TOI-375b orbits very close to its star. The intense heat from the star causes the planet's atmosphere to expand dramatically. Hydrogen and helium gases heat up and stretch outward. This makes the planet appear much larger than its actual core. Now let's compare its size. Compared with Jupiter, TOI-375b is roughly similar in overall radius. But when compared with Earth, the difference becomes mind-blowing. Earth could fit inside Jupiter more than 1,300 times by. And since TOI-375b is nearly Jupiter size, that means thousands of Earths could fit inside this giant world. Just imagine looking at Earth from the perspective of such a massive planet. Our entire world would appear incredibly tiny. Because the planet orbits so close to its star, it likely experiences extreme temperatures. One side of the planet may constantly face the star, creating a scorching hot day side. The opposite side may remain darker and slightly cooler. This temperature contrast could generate powerful atmospheric winds. These winds might reach speeds of thousands of kilometers per hour. Storm systems larger than continents could swirl across the atmosphere. Lightning flashes might illuminate gigantic cloud layers. From space, the planet could appear like a giant swirling ball of gas. But this strange world is only the beginning, because deeper within this system lies an even more massive giant. Planet 2, TOI-375c. Next we travel to TOI-375c. If TOI-375b is the puffy marshmallow, then TOI-375c is the heavyweight champion. This planet is significantly more massive. Its gravity would be tremendously strong. When gas giants become more massive, their atmospheres compress under intense gravitational pressure. Deep inside the planet, hydrogen gas may transform into an exotic state known as metallic hydrogen. This strange form of matter behaves like a liquid metal. Inside Jupiter, metallic hydrogen is believed to generate the planet's powerful magnetic field. But TOI-375c may possess an even stronger magnetic environment. That magnetic field could trap enormous numbers of charged particles. These particles would create powerful radiation belts around the planet. If this world has moons, they might experience incredible auroras. Auroras occur when charged particles collide with atmospheric gases. On Earth, these appear as beautiful glowing lights in the sky. But near giant planets, auroras can be much larger and more energetic. Let's compare sizes again. TOI-375c is similar in scale to Jupiter, possibly slightly larger. But compared with Earth, it is enormous. Earth would appear like a tiny marble next to this massive gas giant. If you were orbiting this planet on a nearby moon, the view would be breathtaking. The giant planet would dominate the sky. Massive cloud bands would stretch across its atmosphere. Storms larger than Earth might swirl across its surface. And glowing auroras could light up the polar regions. But even this enormous planet is not the most intriguing member of the system. Because farther out lies another giant world with a very interesting orbit. Planet 3, TOI-375d. Our final destination is TOI-375d. This planet orbits much farther from its star than the previous two planets. In fact, its orbital distance is surprisingly similar to the distance between Earth and the Sun. But instead of a rocky world like Earth, this region is occupied by a giant gas planet. Imagine if Jupiter suddenly replaced Earth in our solar system. The sky would look completely different. Instead of a single moon, there could be dozens of moons orbiting the giant planet. Some of these moons might contain underground oceans. Others could be covered with ice or volcanic landscapes. Large gas giants often host complex moon systems. For example, Jupiter has more than 90 known moons. Some of them, like Europa, are considered potential locations for extraterrestrial life. A similar situation might exist around TOI-375d. Although scientists have not yet detected moons there, the possibility remains exciting. In terms of size, TOI-375d is comparable to Jupiter. And once again, when compared with Earth, the scale difference is staggering. Thousands of Earth-sized worlds could fit inside such a giant planet. Gas giants like this can also shape the architecture of their entire planetary system. Their gravity influences the orbits of smaller bodies. They can deflect comets and asteroids. In our own solar system, Jupiter acts like a cosmic guardian, helping shield inner planets from some incoming objects. TOI-375d may play a similar role in its system. Final thoughts: a universe full of strange worlds. The TOI-375 planetary system shows us just how diverse planetary systems can be. 3 giant planets, each with completely different characteristics. A puffy, inflated gas giant close to its star. A massive heavyweight world with powerful gravity. And a distant Jupiter-like planet orbiting at Earth-like distance. All circling the orange glow of the star TOI-375. Discoveries like this remind us that our solar system is only one small example of how planets can form. Across the universe, there are billions of planetary systems, each with its own strange worlds and cosmic mysteries. And with every new discovery, we come one step closer to understanding our place in the cosmos. The universe is vast, and somewhere out there, many more incredible worlds are waiting to be discovered.